Hello, everyone, and welcome to a new episode of the Tek Caffe Podcast. I'm Ahmed Misbah, and today Khaled and I are going to talk about implementing BDD scenarios with CuNesse. I'll start first with introducing myself and Khaled. I'm Ahmed Misbah. I'm founder of Tek Caffe. I'm also a chief architect, coach, and instructor. I'm a speaker at the DevOps Days Cairo conference, webinars on the Software Engineering Competence Center, the Africa and Middle East Conference on Software Engineering, the Google Developer Group, Orange Dev Test Days, and Delta Technopreneurs. I like to talk about a lot of topics. Those include software architecture, cloud native architectures and beyond, free and open source software, agile, lean, and DevOps, and BDD is an agile, call it methodology, process, practice. So it's a part of what we like to talk about. And last but not least, artificial intelligence and machine learning. I have about 20 years of experience in software development. I've delivered 2 award-winning innovative solutions, winner of the 𝗘𝗏𝗵𝗃𝗀𝗀𝗀𝗀𝗃 2022 UI UX track. I'm a PhD candidate working on an Arabic large language model, and I have a master's degree in machine learning, specifically in opinion mining, and many other professional certifications. Khaled 𝗕𝗵𝗃𝗀𝗀𝗀𝗀𝗀𝗀𝗀 is an instructor and speaker at Tek Caffe, and he's also a software engineer at Orange Innovation Egypt. He's also a speaker at the Orange Dev Test Days, and he and I were both winners of the 𝗘𝗏𝗵𝗃𝗀𝗀𝗀𝗀𝗀𝗀 2022 UI UX track. We were in the same team. So before we start, I want to talk a little bit about Tek Caffe. So Tek Caffe is a startup dedicated to empowering the tech community and inspiring innovation in the tech industry. Along with the Tek Caffe podcast, we offer 2 professional services. Those include technical workshops and technical consulting. And we'll be talking about those in more details at the end of our presentation. Since its launch, the Tek Caffe podcast has aired around 24 live episodes on LinkedIn and YouTube, and you can find the recording on our podcast on YouTube. We've had many great guest speakers talk to us about many different topics, including agility, mobile software development, technical practices, artificial intelligence, etc. So a big thank you to all of our guest speakers. Tek Caffe was community partner with the Startups Without Borders and Impact's CV Connectors. And we were also silver sponsor of the DevOps Days Cairo Conference 2023. Okay, let's see what we are going to talk about today in our episode. So, since we're going to be talking about implementing BDD scenarios, it would make a lot of sense to start first with talking about BDD, what it is, how BDD works, the benefits of BDD, what BDD is not. That's basically all the misconceptions around BDD. The CuNesse story, which is basically the tool that we're going to demo to you today. And last but not least, Khaled is going to show us some great demos to show you how we can implement BDD scenarios using CuNesse. So let's start first with an introduction. What is BDD? I got this definition of Wikipedia in 2022, and I think it's a really good definition. So BDD is an agile software development process that encourages collaboration between developers, testers, and customer representatives in a software project. It encourages teams to use conversation and concrete examples to formalize a shared understanding of how the application should behave. And you will notice that we have underlined the most important terms in this definition. So it's a process, meaning that it's end-to-end. So it starts from when you've got an idea up to the part where you deliver working software to your customers or your end users. It promotes collaboration, which is a very, very important practice if you're doing agile software development. And it promotes collaboration between three very important stakeholders. Those are business, developers, and testers, because each one of these stakeholders has a very good perspective when they're collaborating in all aspects of the software development, starting from the requirements up to the code and ending with running tests, reports, etc. So if there's going to be collaboration, there's obviously going to be conversation around something. So classically, the conversation was around user stories. If you're doing TDD, the conversation transfers from the user stories to the tests. And now BDD takes that to a new level, and that is having a conversation around concrete examples in order to make the understanding about a piece of requirement shared and concrete about how the application should behave. So this is basically what BDD is. It's a process. It's about collaboration and conversation. It's about using concrete examples to formalize a shared understanding of how an application should behave. A little bit of history about BDD. So BDD was pioneered by Dan North back in the early 2000s. So it dates way back, right after the Agile Manifesto was written, and it was introduced in an article by Dan North called Introducing BDD. It grew from a response to test-driven development to help programmers on new Agile teams get straight to the good stuff of knowing how to approach testing and coding and minimize misunderstandings. In 2003, Dan North started writing a replacement for JUnit, which he called 𝗔𝗵𝗵, and he wrote that with a couple of other colleagues, which you will recognize, Liz and Chris Matz. And they used the vocabulary of behavior rather than test. BDD was largely influenced by the use of ubiquitous language, which is a strategic design pattern in domain-driven design, and the use of the given when then notation to capture the acceptance criteria of a user story and turning that acceptance criteria into executable specifications. BDD has then evolved into both an analysis and automated testing at the acceptance level. Yeah, it started growing in popularity from 2004. So in the words of Dan North, BDD is about using examples to talk through how an application behaves and having conversations about examples. So yeah, it was first around user stories with their title and acceptance criteria. And then with BDD, it's not just about the user stories. It's also about explaining the user stories with concrete examples, which you can turn into executable specs. Okay, now in the definition, we've said that BDD is a process. So let's see how that process works. So it starts with the team discovering and writing down user stories. Then from these user stories, teams start discovering examples for these user stories. After that, they move to the formalization phase, where they start writing down these examples using some sort of domain-specific language. Once they have the examples written using a DSL, now we have executable specs, which we can automate, turn into automated tests, and turn the automated tests into the production code, then deliver this production code as working software. So it's basically discover, formulate, automate. The discovery part is when you collaboratively decide on what is to be built with concrete examples. Formulation is when the concrete examples are turned collaboratively into executable specifications. And then the automation is when specifications are turned into both test and production code using an outside-in approach. So yeah, and this diagram here that we got from John Smart's website basically summarizes what we have just explained. So you've got the discovery phase where you have the three amigos. Those three amigos are usually some representative from business, a representative from development, and a representative from testing. And it doesn't have to be three people, but it has to be these three functions. So they use some sort of discovery workshop in order to be able to discover the examples. Then they move to the formulate phase, and this is what John Smart calls the Gherkin gang. So this Gherkin gang turns the examples into executable specs, and then we move to the automation. Okay, we turn the executable specs into automated tests, and from the tests we drive the production code and we deliver production code to our end users, of course in an incremental and iterative manner. Okay, now that we have described what BDD is and talked a little about how the BDD process works, let's talk about the benefits of BDD. So we've said BDD is about collaboration. So obviously you get strong collaboration when you are working with BDD. And as you've seen here, in the discovery phase, you've got the three amigos collaborating together to discover the examples, business rules, acceptance criteria, etc. In the formulate phase, you have the Gherkin gang, which can also be the three amigos, collaborating together in order to write the executable specs. Then when it comes to automation, you use some sort of collaborative programming technique that could be pair programming or ensemble programming in order to write the automated tests and basically use the red-green refactor mantra. So yeah, you get that strong collaboration with BDD. And as I've said, the agile mindset is all about collaboration and communication. You get higher engagement, collective ownership of almost everything. The executable specs, the examples, the tests, the code. You focus on business value. You deliver the user's needs. You increase confidence and courage, especially with the byproduct of all of this, and that is the nice automated test suite that you get. It gives you the safety net, which increases your confidence and courage. The confidence and courage to refactor and change the behavior of the code. You get improved quality. And that's something that you get when you're doing red-green refactor. Because the refactor phase is where you focus on the design. And when you're focusing on the design, you get good quality structure, which in returns translates to good quality code. You also get the shared understanding, okay, because of the collective ownership and the strong collaboration. You get business readable specifications. And these business readable specifications are also executable specifications. So it's something which you can easily turn into automated tests. And you get living documentation. So this is not something that you write once and then throw away. No, this is something that is continuously accessible, that is always accessible, and runs as part of your CI/CD pipeline. So these are the benefits of BDD. And the reason why we like talking about benefits is that they act as a measure, okay, of how good your BDD practice is. So if you're not getting these benefits, if BDD is not delivering on this promise, it's not a problem with BDD. It's definitely a problem with how BDD is being practiced. So when we talk about the benefits, we're basically trying to tell people, this is what you're supposed to be getting from BDD. And if you're not getting that, then you should continuously improve until you get these benefits from BDD. Of course, in an incremental or evolutionary manner, because in software, you never get something right the first time, okay? It's an incremental and iterative process. Let's talk about what BDD is not, the misconceptions. So the first misconception, BDD is a test strategy. Absolutely not. The tests are a byproduct, just like TDD. But BDD is not only about the tests. It's about the collaboration. It's about the communication. It's about the examples. It's about the scenarios. It's about the executable specifications. So it's an agile development process. Because here's the thing. If we say that BDD is a test strategy and your team already has a test team and they're already doing testing, the first thing that is going to come in mind is that, why more testing? Why another test strategy? We already have tests. So take care of this first misconception. It's not yet another test strategy. BDD is also not only about test automation. So obviously, when you have executable specs, you're going to turn these executable specs into automated tests. But again, we're talking about byproducts. But it's not only about that. Why? Because you can do automated tests even if you're working with waterfall. So why another process for automated testing? We are already doing that. So no, BDD is much more than that. The third misconception is, the most popular one, if that's the right term to use. BDD is only GWT. So in a lot of teams, if they are writing their test scenarios using given, when, then, but there is no discovery, there is no Gherkin gang, if there's no test automation, if there's no live documentation, that's fine. It's still BDD. And that's a very big misconception. No, BDD is not only when you use given, when, then to describe your test scenarios. It's actually much more than that. GWT is only a tool that you use in BDD for writing your executable specs, but it's just a tool, and BDD is much more than that. Another misconception, BDD is 𝗘𝗵𝗵. It's like saying DevOps is Jenkins. Again, 𝗘𝗵𝗵 is only a tool. But as we've said previously, BDD is much more than that. The last misconception is that let's just skip the discovery phase. There's no need for that. We have really good requirements. Let's just turn these requirements into Gherkin scripts and automate the scripts, and that's it. As we've said, BDD is discover, formulate, automate. And if you're not doing the discovery, you're missing out a lot, because discovery helps you basically discover your examples. And if you are not able to discover your examples well, then what are you going to turn into executable specifications? And you then get an anti-pattern that is known as accidental discovery. And this is an anti-pattern that you don't want to have. So yeah, this is the list of misconceptions. So BDD is much more than just a test strategy or test automation or GWT or 𝗘𝗵𝗵. It's much more than that. Okay, let's talk about CuNesse. So when it comes to automating the executable specifications, there are many tools and framework. 𝗘𝗵𝗵 is a very popular framework, and it supports multiple programming languages. SmartBear has a nice web-based tool called the 𝗘𝗵𝗵 Studio, which we'll talk about in a little while. And there is Serenity, there is gbehave. You've got a lot of automation frameworks and tools which you can use to automate your executable specs. And they pretty much share this high-level design. Okay, so you write your executable specs using some sort of domain-specific language. Gherkin is perhaps one of the most popular DSLs. And you write fixtures for these scripts. And fixture is a term that is used if people are using Fit for doing acceptance test-driven development. You will be aware. So basically, fixture is the automation code or the test automation code of your scripts. Now you have to run your tests against some sort of test runner in order to practice the tests against the system under test, and then generate these nice reports to tell you what tests have passed and what tests have failed. So yeah, you get the test runner as a component, and of course you got the system under test or the unit under test. So this is basically the high-level design of most, if not all, of your typical BDD frameworks. Now, here's our problem statement. When different team members are collaborating in order to write the Gherkin scripts or the executable specs, if you're using a tool like 𝗂𝗵𝗵 or whatever test tool you're using, and you're doing some sort of collaborative programming like ensemble programming, the developers or the testers are usually going to be sharing the code editor or the IDE. And you've got business people working with you as well. And unless you're a business guy or a product owner coming from a technical background, using the IDE and version control software like Get, etc., isn't going to be your cup of tea. Okay, it's going to be a little bit challenging for you. So this problem is going to act like a barrier. Okay, what if I, the business guy or gal, I want to run the automated tests from a web interface whenever I want? What if I want to experiment with other scenarios or examples? What if I want to have an easy web-based version control in order to see how this executable specification has evolved? This is not something that you get out of the box with 𝗂𝗵𝗵. Okay, if you're going to be using a tool like 𝗂𝗵𝗵, obviously you have to use an IDE or a code editor, and yeah, this has to be complemented by CI/CD, version control, etc. So yeah, this acts like a technical barrier. Okay. And it makes the whole BDD experience, especially for the technical people, not very friendly. Now, yeah, communication is very important. And here I'm showing a figure from Agile Software Development. This is a book that was written long ago by 𝗘𝗏𝗄𝗏𝗃𝗏. And yeah, in this book, he shows this figure, and it shows the relationship between the richness of the communication channel and the communication effectiveness. So we can see that the warmer the communication is, the better the communication effectiveness. So we want the three amigos or the Gherkin gang, we want them to be able to communicate and collaborate over a user-friendly tool that is going to encourage them to have effective communication. So one possible solution was 𝗂𝗵𝗵 Studio. This is a nice tool that SmartBear offers. It allows you through a web-based interface to write down your feature files and execute the feature files at will and see these nice reports for your test runs. How many of the tests have passed, how many have failed, how many were skipped, etc. It also allows you to import your automated tests in order to run your executable specs against these automated tests. So it basically allows you to import your fixtures using a number of frameworks in order to be able to exercise your feature files against these fixtures and against the system under test. And it also offers version control. Okay, so whoever you are, you can always access this web interface and yeah, go through the different executable specifications that you have and see how these executable specifications have evolved. But there's a catch. 𝗂𝗵𝗵 Studio is not for free. It costs money. And for a lot of people, this tends to be a problem. Okay, some people just like free and open source. And the alternative was not really there. So we started looking at tools that offer what Cucumber Studio offers, but that can be adapted to use Cucumber, the framework. And we explored fitness, we explored Concordian, robot framework, and Catalog. And the best option to be adapted was fitness. I personally used fitness long ago, but I didn't use it with Cucumber. I used it with the Fit, and it was a very nice tool. And I said, yeah, it has all of what we want. It just needs to be adapted so that you would be able to use it with Cucumber instead of Fit. So let me just give you a little bit of an introduction about Fitness. So Fitness is a web server, a wiki, and an automated testing tool for software. It is written in Java by Micah, I hope I'm pronouncing that correctly, Martin, with the help of Uncle Bob and others. So the first program supported only Java, but it has been adapted later on to support multiple other programming languages. And it was based on 𝗏𝗏𝗵's framework for integrated tests, and that is Fit. And it is designed to support the acceptance testing rather than unit testing. And yeah, it facilitates detailed readable description of system function. Okay, and yeah, these screenshots basically show you how Fitness looks like. So it's a web application, and it's based on wikis. So you create all of these different web pages to represent static pages just for documentation, or test suites, or test pages. And Khaled will show you this shortly. And as we've said, you write your scripts on this web interface, and then you write your fixtures using Fitness, and you can execute that using this web interface. So yeah, the idea came from there. Let's adapt Fitness to use Cucumber instead of Fit. And from there came the name CuNesse. So it's basically a combination of the two names, Cucumber and the Fitness. And as you can see, we kind of, borrowed ideas from the logo of Fitness and logo of Cucumber and came up with the name CuNesse and this logo. So CuNesse is basically an adapter that allows you to write Cucumber feature files on Fitness and execute it against Cucumber. So yeah, you write the Cucumber Gherkin feature files and run them on Fitness. You write your Cucumber step definitions as you normally do with Cucumber. And yeah, you get this nice web interface which will address our problem statement. And yeah, this adapter was developed both by me and Khaled ElNaggar. I have to be honest, I was more acting like a product owner and a test engineer for this tool. Khaled did all of the coding. So yeah, but it was a collaboration between both of us. Okay, and this is how it looks like. Still uses the same interface as Fitness, but as you can see from the screenshots, now you can write Cucumber feature files using Gherkin script, and you can run those with a Cucumber test system in Fitness's terms and see all these nice reports. And Khaled demoed CuNesse in 2022 in the Orange Div Test days, and it received really good reception. So yeah, CuNesse has been there for quite a while. since the beginning of 2022, and we haven't been doing a really good job promoting for it, and that's why we're doing this episode today. But we do use it and teach it in our BDD workshop. Okay, so that's all from my side. Khaled is going to show you a demo now of CuNesse. So Khaled, I leave the mic to you. Go ahead.
Thank you, Ahmed. Here I open the front page for fitness. As Ahmed said, for fitness is a wiki. It has multiple types of pages. It has a suite page, a test page, and a static page. We can configure the pages as we like, and as you know, a suite page is going to contain multiple tests. This is a very simple UI and very easy to use tool. I will walk you through how to create a suite and how to run against 𝗘𝗵𝗵, and then we will walk through the other features that we implemented here for CuNesse. So we basically create a suite page, and that suite page will have multiple tests. So we'll give it a page name, and that's going to be let's call it our 𝗘𝗵𝗵 test suite, for example. For now, the page, the suite will be empty. Once we created the suite, it appeared here in the contents of the front page. If we enter the suite, of course, it's going to be empty. The test suite is empty. And as Ahmed said, fitness originally or by default runs against fit or against slim, which are other automation tools like 𝗘𝗵𝗵, but they have their own DSL. So before we go ahead and start writing features and scenarios and execute them against 𝗘𝗵𝗵, we'll have to tell fitness that we would like to use the test system of 𝗘𝗵𝗵, and we do that by defining a variable here in the test suite. So let's edit the page, and I already prepared the variables that we're going to define. So here we tell fitness, please run the 𝗘𝗵𝗵 test system and inject or give it the features that we will later do, that we will later make together. And we will also define the glue path for the step definitions for the features that we're going to write in just a minute. Now we've configured our suite to run against 𝗘𝗵𝗵. Ahmed, in his slides, Ahmed mentioned, said the word test runner, because that's used in some of the documentation and in some of the guides. Here, fitness uses test system, but basically we can use them interchangeably, the test system or a test runner. For me, I will call it test system as fitness does, but it basically means both, that we're going to use 𝗘𝗵𝗵 as the test system, which means we will run the feature files or the test pages here against 𝗘𝗵𝗵. Now we've configured our test suite to run against 𝗘𝗵𝗵. Let's add a new test page, which will resemble a feature file. Now let's create a test page. The test page, let's call it our 𝗘𝗵𝗵 feature file. And let's add a very simple feature file. And let's get a feature trying out CuNesse. It will have a scenario that is, for example, first scenario. And we will give it some dummy steps, like given the user is signed in, then the user is authorized. So this feature file has the very basic outline of a normal feature file that's written for 𝗘𝗵𝗵. we name the feature, and we name the scenario, and we have 2 lines or 2 steps. If we run this feature file, this is the report that turned out. We have a yellow line, tells us an exception happened, and then it tells us that for the scenario named first scenario, there are undefined steps, and that is the step that is undefined. The user is signed in, and 𝗘𝗵𝗵 gave us the code snippet for the step definition that will define this step. So we can say that yes, we run against 𝗘𝗵𝗵. This is the returned answer from 𝗘𝗵𝗵 to this undefined steps. Now we're certain, we're sure that we configured the suite correctly, and we run against 𝗘𝗵𝗵. Otherwise, another error would appear that I don't know what systems you're running against, or other errors, but now we're certain that we run against 𝗘𝗵𝗵. That is basically it for creating a test suite and creating a very basic feature file. You can build on this and create as many feature files as you like and as many test suites as you like, and that is basically fitness. Fitness enables us to do all this. Only this line gets executed only when we run the test itself. This is where fitness takes the content of this page and injects it into CuNesse, which runs it against 𝗘𝗵𝗵. Now let's go back to the first page and walk through some of the features that 𝗘𝗵𝗵 supports and that we will showcase here. As we said, in CuNesse, we basically run the feature file that you wrote against 𝗘𝗵𝗵. We don't extend 𝗘𝗵𝗵 per se. We don't do any modifications. Let's look at some of the features that are implemented in 𝗘𝗵𝗵 or supported in 𝗘𝗵𝗵. Let's first look at a passing test. A passing test, well, we have the system on the tests. It is a sort of a calculator or a multiplier. We have a feature that's called multiplication. In the first scenario, we have 2^2 giving a variable x with value 2. When I multiply x by 2, then x should equal 4. And we have another scenario for 3 multiplied by 3, then it should equal 9. Let's run this very simple feature file, and yes, the report is as expected. 2 scenarios were correct, and it highlights the correct scenarios with the green color. Let's take a step back and look at the 𝗘𝗵𝗵 glue that we defined. Now here we provided the path for 𝗘𝗵𝗵, or for the 𝗘𝗵𝗵 glue, or the step definitions that we have. If we look back at the step definitions that we have in the source code, we will find them exactly defined here in the package that's called 𝗘𝗵𝗵 step definitions. This is the path that we provided here. It is exactly the same. We don't need to do anything more than that to configure the suite. Whatever step definitions you have here, doesn't matter how many you have, what are the configurations, as long as you've provided the correct path and the correct package, it will be implemented into 𝗘𝗵𝗵 and run successfully against it. So the passing test, we know that this line, this step was executed here, given a variable x with y when I multiply x by etc. And these are the 3 steps that we basically did here. If I'd like to add new steps or more steps, I can write them, take the snippet, add these steps here, and rerun the test. That was a passing test. Let's take a look at a failing test. In this failing test, I named a feature as failing test, and 2^2. Well, definitely 2^2 shouldn't equal 45. Let's run the test and see how it gets reported. Yes, a red line, that there are 2 wrong scenarios. We report that the first line ran successfully, nothing wrong here. The second line ran successfully. The third line, x is 45, that is the actual, but it should be 4, and that is the expected. So we tell you what line failed, how it failed, and the error or the exception that was thrown. Very easy to understand this report, I believe. Let's take another example. Let's look at let's take a look at another one or two. The passing error. As you know, in the Gherkin script or the Gherkin syntax, we should start a new line by either a feature or a scenario, giving, when, then, or scenario outline or example. There are certain keywords that we should start a new line with. According to the Gherkin syntax, here we added a non-Gherkin text. Now this line is undefined because let's run it and see how the system reports it. It is reported as yes as an exception, and the test execution failed to pass the resource at, and gives us the feature file. It tells us that expected to be end of file or step line or tag line or run line, but it got non-Gherkin script. All of this comes with CuNesse. You can see we must define the test system to be 𝗘𝗵𝗵, and 𝗘𝗵𝗵 does not come by default with fitness, only fit and slim, which are, as I said, other automation frameworks. They have their own DSL. If you'd like to use 𝗘𝗵𝗵, if you like to use 𝗘𝗵𝗵's Gherkin scripts and outlines and scenarios and etc., and run them against 𝗘𝗵𝗵, you'll have to integrate fitness with 𝗘𝗵𝗵 using CuNesse, which is basically what we did. Another example is the parameterized tests or parameterized scenarios. We have a new feature, we have a scenario outline, and we provide the examples, and the scenario will run for each one of these rows, and then we have another scenario. So let's run it, and yes, it works. Every row in the table was taken, the values were taken and substituted in the scenario outline, and it ran. So most, if not all, of the features in 𝗘𝗵𝗵 are supported with CuNesse. Let's run the whole suite to see how the report is generated. Now this is the whole suite running all the features or the feature files that we have provided. So it tells us how many were right, how many were wrong, how many exceptions were thrown. I think very easy to read, very easy to detect what changes happen. So, for example, if this was an old acceptance test and there were new modifications or changes to the system that you have, when you run the suite, it will tell you which tests failed, which tests broke because of the new changes, and so on. Most of the features in CuNesse are supported here. And I think this is a good introduction to fitness itself and to CuNesse, which is the integration of both. As we said, we don't add anything specific to CuNesse or fitness. We simply run the feature file against 𝗘𝗵𝗵 itself. So this is regarding this demo now. Obviously, this demo is very simple, and it only consists of 2 or 3 steps. It isn't that complex. I'd like to show another demo that we prepared. Now that demo has a slightly more complex requirement. So let's go to. It's a game called 𝗕𝗏𝗵𝗃𝗃𝗵𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃 simple text-based adventure game where the player navigates through a cave system to hunt a monster that's called the 𝗏𝗵𝗃𝗃. Now the game has quite a few more rules and quite a few more hazards and dangers that exist in the cave system. If Ahmed would like to explain the rules of the game.
Yeah, sure. So this is how the map or the graph of the game looks like. So you've got basically 20 caves which are connected to each other, as the graph shows. And yeah, the target of the game is for the player to move through these caves and to basically shoot arrows to try and hunt down the 𝗏𝗶𝗃𝗃. Of course, the player could lose the game if the 𝗏𝗏𝗃𝗃 eats the player before the player gets the chance to shoot it down with an arrow. As Khaled has said, there are some hazards. So if you move to a cave where there are bats, the bats are going to move you to another random cave. And some caves have pits. So if you move into a cave where there's a pit, you fall into this pit and you lose the game. So yeah, this is pretty much, those are pretty much the rules of the game. There are more rules, but I think this is, just enough rules for Khaled to be able to show you the acceptance tests that we have written with Fitness and 𝗂𝗵𝗃 using CuNesse to test the game. So yeah, Khaled, back to you.
Okay, thank you, Ahmed. Now we should be familiar with this page. This is the front page for Fitness Wiki. We have already defined a suite, a test suite that's called 𝗏𝗏𝗵𝗃𝗃𝗃. It should contain all the feature files or the acceptance tests that we wrote for 𝗏𝗏𝗵𝗃𝗃 game. Now, of course, you can modify this page as you can modify it to your liking. There are different tags, different headers, and different components. You have to gain a little bit of fitness knowledge to be able to utilize it to the maximum, but it's up to you. Now we created the bare minimum of the front page. Here is our test suite for 𝗏𝗏𝗵𝗃𝗃𝗃. As we already seen together, we have to define the test system is 𝗂𝗵𝗵. Otherwise, Fitness will probably runs by default against fit or against slim. I don't remember. And then we define the 𝗂𝗵𝗵 glue or the step definition path. These are the feature files or the test pages which represent the feature files. We have decided to group them into these different features. Now this is a failing test. I think I added it for the purpose of viewing the report. Here's the game initialization features and the features related to when the player moves, when the player senses danger, and when a player shoots. Now we can easily read through them. We can open the player move and read what is the logic for when the player moves. That the player should be allowed to move successfully to a cave and etc. You could easily learn about the system, learn about the game, and this is the benefit of acceptance tests and BDD in general. They have working documentations or living and executable documentations. Now, say that I'd like to explore how the player shoots. Now we open the feature file regarding how the player shoots, and it has a title, it has a description, it uses a background to initialize all the actors that we saw before, everyone in the cave. And let's read the first scenario. It says when the player shoots, the scenario's title is the player shoots the 𝗏𝗏𝗃𝗃𝗃. And the summary is if the player shoots a cave that contains the 𝗏𝗏𝗃𝗃 should die and the game should be over. And we start the player in cave 9, and the 𝗏𝗏𝗃𝗃 in cave 18, the player moves to cave 10, etc., etc. The player shoots the cave that contains the 𝗏𝗏𝗃𝗃. The 𝗏𝗏𝗃𝗃 will be dead and the game is won. Now, say that I'm one of the business team or one of the stakeholders in the team. I'm either a developer or a tester or the product owner or whoever stakeholder, and I wanted to experiment a little about how the system is implemented. I want to think of a hypothetical scenario. I'll I'll easily be able to edit this feature file, add my scenario, and run and see how my system will behave. So let's edit this feature file, and let's create a new scenario. Let's call it. I'll make a scenario where I miss the 𝗏𝗶𝗃. I'll shoot at a cave that doesn't contain the 𝗏𝗏𝗃. So let's call it scenario player shoots the 𝗏𝗏𝗃 and but misses. Let's call it the player tries to shoot the 𝗏𝗏𝗃 but shoots at an empty cave instead. This is the summary for this scenario. We'll initialize the player and the 𝗏𝗏𝗃 in the caves. So let's take the same initialization that we had in this scenario and we will modify it. So the player starts at cave 9 and the 𝗏𝗏𝗃 in cave 18. Then the player moves to cave 10. So eventually we'll have the player in cave 10 and the 𝗏𝗏𝗃 in cave 18. Here is the player in cave 10 and the 𝗏𝗏𝗃 in cave 18. We'll make the player shoot at cave 9, for example, to see how the system behaves to a missed shot. When the player moves to cave 10, when the player shoots at cave 9, for example, I'll then check that the 𝗏𝗏𝗃 is dead. Now the 𝗏𝗏𝗃 shouldn't be dead, but I'm experimenting. I want this test to fail because I shot at an empty cave. Then this line shouldn't pass indeed. So I'm experimenting for now. Now I created the scenario. I think that will be all for the scenario. Let me run the whole feature, and we will give it a run. Yes. We have our scenario. The player shoots the 𝗏𝗏𝗃 but misses. It definitely failed on that the 𝗏𝗏𝗃 will be dead because it's expected something, but something. Well, maybe there's. Okay, we have the scenario failed because the 𝗏𝗏𝗃 should not be dead, and that is correct. Now I'm happy. I'll go back, modify the scenario and call it, and then check the game is still on. Should be so, and the game is on. Should be the game, and the game's on. Yes, and the game is still on. So as I said, as the stakeholder who didn't know how the system will behave when the 𝗏𝗏𝗃 shoots at an empty cave, I easily navigated to the correct feature file, correct test suite, and correct feature file, created my own scenarios, ran a test. Maybe I want to run another scenario where the game is a draw, so the player didn't win or lose. Now I don't know if we already have a draw status for the game or not, but let's run it and see how the system behaves. Okay. We have the game draw as an unknown, undefined step. So now, as the product owner, I know that we don't have this this state or this feature. So maybe I can introduce a modification or a new behavior or something, or have discussion with someone. But I know very well what the system can do and cannot do. And I think
I may interrupt you, Khaled. So actually, the example you've just shown us right now, and when I say example, I'm referring to the demo and not an actual example in the feature file itself. So this shows you how basically you can reuse your fixtures in order to play around with other scenarios and examples in order to see how the system is behaving. And you've seen that when Khaled was adding new scenarios to the feature file or modifying them, he didn't need to modify any code because the fixtures have already been written, or the 𝗘𝗵𝗵𝗃𝗃 test definitions, step definitions have already been written. And this is our selling point here, okay? That if you've got fitness deployed somewhere and is accessible to anyone in the team, people can just access whatever feature file they want, and they can start playing around and seeing if maybe they've missed some example or some test scenario, and they want to see if the system accepts this behavior or not. And if this is something that they have missed, they can have a meeting, have a conversation, and say, hey guys, I've tried this scenario and it failed, so let's implement this scenario into the system. And then it's an outside-in approach, red-green refactor, until the feature is implemented and delivered. So yeah, the example that Khaled has just shown right now really demonstrates the power of using fitness with CuNesse, in that there isn't this technical barrier that we've talked about in our problem statement. Khaled rarely went to the IDE or the code editor. He was playing around on the wiki. And yeah, if something doesn't run on the wiki, you can always have that conversation with the testers or with the developers and see how we can let this scenario or test pass. So that was a really good example, Khaled. Thank you very much for showing us that. It really showcases the power of CuNesse and how it addresses the problem statement that we have talked about before showing the demo.
Thank you.
Okay, yeah. So if you are done, Khaled, I think yeah, we can declare this as done. We have shown people the demo, unless you have other stuff to show. Maybe we can move back to the slides. So the example that Khaled just showed you is available on GitHub. So you can scan the QR or basically type in the URL below and get access to the repo and play around a little with CuNesse. If you have any problem accessing the repo, please get in touch with me on LinkedIn, and yeah, we'll get this sorted out. So yeah, thank you very much, Khaled, for that demo, and I hope people find CuNesse as useful as we found it useful. And of course, feel free to, this is still work in progress, so we have other features that we want to add to CuNesse. It's in the roadmap, and yeah, we may have other sessions in the future to show you whatever updates that we add to CuNesse. Okay, so coming up on the Tek Caffe Podcast tomorrow, Tuesday, March the 5th, we've got this exciting session that is going to be delivered by 𝗵𝗁𝗵𝗃𝗵𝗁𝗃𝗃𝗃𝗃𝗃𝗃𝗃, the author of Scrum for Hardware Explained. And in this session, 𝗵𝗁 is going to talk about his latest book and talk to us about how we can apply Scrum in hardware and in manufacturing in general. I've personally read the book. It's a really, really good book. And it has a lot of stuff which I think to many is going to be brand new. So yeah, don't miss out this session tomorrow by Paolo on the Tek Caffe podcast. It's going to air live from Cairo and Italy on LinkedIn and YouTube at 6 p.m. Cairo time. So yeah, and don't miss out the live session, because it's a great chance for you to ask the guest speaker whatever questions you want. Let's talk a little about our services at Tek Caffe. So a few weeks ago, Khaled and I delivered a behavior-driven development workshop to our latest client. It was a big success, and we got very positive feedback from the client on this. And if you're interested in this workshop or any other workshop that Tek Caffe offers, access the Tek Caffe website and fill in the contact form or send us an email. And yeah, let's have a conversation around how we can deliver one or more of our technical workshops to you. Tek Caffe doesn't only do behavior-driven development. We also have courses and workshops on modern extreme programming, test-driven development, effective user story writing, DevOps, refactoring, software architecture, software design, system design, domain-driven design, scaling agile teams, and working as agile teams. So yeah, if you're interested in any of these courses or workshops, just access our website and fill in the contact form, and we'll get in touch with you right away. Visit our website, tekcafe.com, by simply writing down the URL on your browser or scanning the QR code. And make sure to follow us on LinkedIn to watch previous recordings and get the latest updates on what we are doing on Tek Caffe. Thanks a lot, and we hope you've liked this episode. We can wait just for 1 minute to see if we have any questions. Let me check them now on StreamYard. I don't see any questions yet. Maybe we can just wait for 1 minute. Okay, so even if you've missed the live session now, you can always just send us a question by leaving us a comment on the events page on LinkedIn, or a comment on the recording on YouTube, and we'll be more than happy to answer any of your questions. And yeah, so I guess that's pretty much it. Thank you very much, and we'll see you tomorrow in our next episode. So wherever you are, have a nice day. Thanks a lot. Bye-bye.